Good morning, Math Principals, second period. I'm sorry I can't be there with you today, so you do have a sub, but I'm just in a credential meeting, so I'm still online, and if you have any questions at all, just please email me, and I'll get back to you as soon as I can. So what you guys need to do today is watch this whole video and take notes throughout. I will upload these notes as well to Google Classroom eventually, but I do want you to take your own notes first. Once you're done taking notes on the video, please do the 3 Khan Academy practices that are assigned to you for today. You will also have a sub next Thursday as well. I have another meeting at the exact same time. So again, I'll do this exact same thing where I make you guys a video and you're all ready to go. So hopefully this all works out okay. Alright, so today we're focusing on adding and subtracting polynomials. So first let's talk about what a polynomial is. Okay, so a polynomial is an expression or a function that consists of multiple terms. And in order to be considered a polynomial, the exponents must be positive integer exponents. So the only types of exponents you can have in order to be classified as a polynomial are the exponents such as 1, 2, 3, 4, 5, and so on. Okay, all the way up to infinity, right? So you cannot have an exponent that is a 1/2 or a 3/4 or a -2 or a -1, right? They all need to be positive integers. So 1, 2, 3, 4, 5, etc. Now there are also different types of polynomials. So a polynomial could have just one term, okay, and that makes it a monomial. Monomial. Now you guys know I suck at pronouncing things, but it's a monomial, right? So it has one term. Okay, so -2x to the 5th power is just one term that is a positive integer exponent, so we're good to go. Okay, and then a binomial has 2 terms. So terms are separated by the adding and subtracting signs. Okay, so if you're adding or subtracting things together, those are 2 terms. Now, the term 5 is a positive 5, right? So that positive stays with the 5. But just know that in order to help you count the terms, you look to see how many things are being added or subtracted. So for the trinomial with 3 terms, we have 3x, -8, and positive 4x to the 5th. So like we have 3 terms here, and you want to remember that this term that's in the middle is -8. So that negative stays with the 8. It doesn't make it 4 terms like the negative is its own term. Does not happen like that. So the 8 is with the negative. So -8 is a term. So there are 3 terms there. And then anything past 3 terms, excuse me, or a polynomial, you would just basically say like how many terms are in it. So 4-term polynomial, right? Here we have 4 terms. So it's a 4-term polynomial. If you had 5 terms, it'd be a 5-term polynomial, and so on. Okay, so I'm going to go and scroll down. If you want to pause throughout this video, that would be a good idea so you don't feel overwhelmed with the notes. Pause whenever you need to. Go back whenever you need to. Alright, so one thing you guys want to notice here is there's something called the standard form of a polynomial. Okay, whoa, that made it super big. So a standard form of polynomial, mind you, I'm making this at 1 a.m., so please excuse any words I say that don't mean to come out of my mouth. So standard form of a polynomial has specific requirements you have to meet in order to be considered in standard form. I will tell you guys that these 2 polynomials are not in standard form, and you'll see why in just a moment. So standard form has several criteria, like I said. The main one is that in standard form, the exponents or the degree descend as the terms are listed. So this example is examples in standard form. Okay, now these examples all only have x as the variable, so I'll talk about what happens if you have like an x and a y and a z or something like that. But for these problems here, if you look at all of these polynomials, all of the exponents go down. So I'm just going to highlight all these. And you might notice on the x's do have an exponent. It's just 1. Remember, we don't have to write x to the first power, but we know that it is x to the first power. So as you look here, the numbers get smaller in the exponents as you go from left to right. So that is what it means by descending, okay? It's going down as you go from left to right. It's decreasing, okay? So here we go from 2 to 1. They get smaller. Here we go from 3 to 1. They get smaller, right? So if you were given an example that was not in standard form, like over here, let's go ahead and try to rewrite it. So this in standard form, we need that x squared to come first. So we're going to take this entire term, negative 12x squared, and put that first. Okay, that term needs to go first. So I'm going to write here negative 12x squared, and now that positive 6x can come, and that one is in standard form. So all I'm doing is just reordering the exponents that are the highest to go first. Okay, so here's another example. We have 1, negative 3x to the 4th, 2x, and x cubed. If you want, go ahead and pause the video and try it on your own just to see if you understand what you're supposed to do, and then check your answer with mine. So the first term needs to be the one with the highest exponent, and the 4 is definitely my highest exponent here. So I'll have negative 3x to the 4th, and then I have a positive x cubed, and then I have a positive 2x, because that's just x to the first power, right? And then I have my constant. So the constants are the ones without the variable. Okay, so constants have no variable. I'll go and write that down up here. So here, constants have no variable and always go last when writing in the standard form. Constants are always at the end. So we have this other one as well here. This one we have 12, positive 12x squared, positive 12x to the 4th, and positive 12x. Now all these numbers are 12s just to show you that the coefficient, which is the number in front of the variable, the coefficient does not matter. What matters is looking at those exponents. So I know that my x to the 4th is the biggest, so I need to put that first, 12x to the 4th. And then my 12x squared is the next biggest, so plus 12x squared. And then my 12x is the next biggest, 12x to the 1st. And then my constant goes last, plus 12. Okay, so now that one's in standard form, and this one was as well. Another piece that I did not find an image of, but I'll go ahead and jot down here. They must, or I guess we should say variables. Variables must be in alphabetical Sorry, I'm out of room. Actually, we'll make that a little bit bigger. Uh-oh. Sorry, guys. There we go. Alphabetical order. Okay. So here, what I'm going to do is give you guys an example of one that's not in alphabetical order. So let's say that I have a 3c plus 2b minus a squared b, okay, minus 4c cubed. All right, so I'm like, all right, crap, that's not in alphabetical order. Also, not all of my exponents are ordered from greatest to least. So we got to reorder these, okay? So the first one I notice, I look for the lowest letter in the alphabet, and that would be my A. So since I have no other terms that have an A in it, I'm going to write this negative A squared B to go first. Okay, and that is one term. So that A squared and B, they're being multiplied, so that's considered only one term. Okay, and then I have my B. That's the next letter in the alphabet, A, B, C, right? So now we're going to have plus 2B, and I have no other B's to worry about. And then I see my C, 3C. But that's not the only term with the variable C. I also have negative 4C cubed. So which one needs to go first? I have to list the highest degrees first in each polynomial in order for it to be in standard form. So negative 4C cubed needs to go first because that exponent 3 is higher than this exponent of 1. So then plus 3C will end my polynomial in standard form. And now this would be the correct way to write it in standard form. And all my like terms are combined already, right? I had no like terms to combine. So that's also very important. In today's lesson, we're going to be practicing combining like terms. So pause here if you need to take these notes down. All right, so our first example is from the Khan Academy practice on adding polynomials, the intro. So once you do this example, I recommend pausing the video and going to do this Khan Academy practice and see how you do. Okay, so for this one, it's relatively simple. Since we just have the positive here, adding, we don't have to worry about the parentheses. Now we are adding this trinomial, has 3 terms, 1, 2, 3, plus the binomial. And that's what it wants you guys to recognize, is that we're adding a trinomial plus a binomial, but since we're adding, we technically don't even need to have the parentheses. With subtracting, we'll have to worry about distributing the negative, but for adding, the terms inside just stay the same because positives will not change the sign at all. So now what you guys have to do is add like terms. Okay, so here I see that I have no other negative 2k cubed. So what I'm going to do is go and use a highlighter, some highlighters to color the like terms. So negative 2k cubed is all by itself. There's no like terms for that one. So that's good. And then we have k squared. So we have negative 7k squared. And we have positive 6k squared. So those two are like terms. And then we also have a positive 5k. So my k terms and a positive 3k. So now you guys have to realize, okay, what number goes first? So once you see what terms you have to combine, you need to make sure to write in standard form. You could always combine your terms first and then make sure that you rewrite it in standard form, but it's totally up to you. So I see here that my negative 2k cubed needs to go first, so my k cubes need to go first. And then my k squareds need to go next, because that's the next highest exponent. And then my k's need to go after that. So I'm just kind of color code here. So negative 2k cubed is the only term that has k to the third power. Negative 7k squared plus 6k squared needs to be combined. So the coefficients negative 7 plus 6 is negative 1k squared. You could also just write this one as negative k squared. The 1 is not absolutely necessary, but it's totally up to you. Khan Academy should not mark you wrong if you do or do not include the 1. It just must be a negative because negative 7 plus 6 is negative 1. And then here we have 5k plus 3k will be a positive 8k. So in Khan Academy, if you were doing this problem, you would have to set up your answer in standard form. Otherwise, they will mark it wrong because they specify in standard form. It's very important. Okay. This would be your answer in Khan Academy for this problem. So go ahead and pause the video and go do this specific practice in Khan Academy. Use the hints if you do need them, and then redo the practice until you get 70% or higher on Khan Academy. All right? And then you can come back to this video to do subtracting polynomials. So go ahead and pause at this moment. Okay, subtracting polynomials. So this one is just one more step. It's the same idea as adding polynomials, but now our first step is not to add the like terms. Okay, our first step is going to be to distribute the negative. Since we are subtracting, we're subtracting a trinomial from a binomial. So we have a binomial minus a trinomial. And we have a negative in there. Okay, so that negative is so important. You cannot forget about that at all. You have to distribute that negative to each of these terms inside. Distributing means you multiply by whatever's outside the parentheses. So basically, we're just multiplying each of those terms that are inside that trinomial by a negative. So these terms over here will stay the same. So we want to rewrite them. Okay. But this one here, a negative times 2x cubed, will give us negative 2x cubed. Negative times a positive is a negative. If you guys forget about that, you can always draw this triangle to see like what your sign would be if you multiply by certain things. So there I'm multiplying the negative times a positive. So if I cross out or cover with my hand a positive and a negative, I know my answer will be a negative for that problem. Okay? And then the same thing here, we are doing a negative times a positive 3x squared. So I know that a negative times a positive, if I cross those two out, I'm left with a negative. So this would be a negative 3x squared. Okay, and then I have a negative times that negative x is my second one. And the reason why I was just going under to limit it, but I'm just following these arrows. So negative times negative x. Okay, if I scribble out the two negatives in my triangle, I'm left with a positive. So that tells me a negative times a negative is a positive x in this case. So now we move on to what I will go ahead and call step number 2. Okay, so step number 2 is to add the like terms. Well, we have to identify them first, and technically I guess I should add here. We want to add or subtract, right? Because it might be subtracting. So let's change this to combine like terms, because you're going to add or subtract. So combine like terms. And I guess honestly I should probably go ahead and change it up top as well. So up here, instead of saying add, that one we had some negatives as well, so technically we were subtracting some of them. But you want to combine like terms, so just any like terms, combine like terms. Sorry about that, I should have said that, combine like terms. So I just picked one color to start off, so I have a 3x cubed, so I want to see if I have any other terms that have an x cubed, and I do. I have negative 2x cubed. So I know that my x cubes are going to need to be combined. And I'm just using that color as their color. And then I have 4x squared. So I want to see if there's any other x squareds. And there is one term, negative 3x squared is another one that I'll have to combine. And then last but not least, I have this x all by itself. There's no other terms left, so that x will just be brought down here. So first I have 3x cubed minus 2x cubed, my blues here. 3x cubed minus 2x cubed is just 1x cubed. You can either write a 1 in front or you don't have to. Okay, x cubed. It is positive. For the yellows, we have 4x squared minus 3x squared, which would be a positive 1x squared. Again, technically, you guys don't need that 1 there. Okay, if you don't want to write that 1, you could just write plus x squared. Either way should be correct. It's totally fine. And then we only have this x left, so plus x. So all of your coefficients are 1. That's okay, it doesn't matter, right? So your final answer will be x cubed plus x squared plus x. Or if you really wanted to, you could write 1x cubed plus 1x squared plus 1x. It doesn't matter. This one I would say is simplest form, in my opinion. So I would say that one's the simplest form. So I would pause this video now and go do the second subtract polynomials intro practice. Get 70% or higher. Okay, I'm going to keep on saying that so you guys get full credit on the Khan Academy. And then once you're done with that, come back to this video, and I have 2 examples for your last Khan Academy practice. So this practice is adding and subtracting still, but you have to apply it given the information they give you. So here I know E equals 6c squared minus 2c minus 1. Okay? And then I know that F, let me use a more distinct color here, that F is negative 4c squared plus 7c plus 5. They tell us that they want us to add E plus F. Your answer should be a polynomial in standard form. So it's so important you guys make sure that you are doing it in standard form, okay? So here, what I'm going to do is I'm just going to duplicate these things. So if I have E plus F, oh, that's not going to work. I got to copy it. There we go. So if I have E plus F, that, row. Sorry guys, this is not working out how I planned. There it is. Okay, I'm going to write it over here. Okay, so E plus F is equal to, we have E here, okay? So we have E and then plus, and you guys will just be rewriting this, plus F. Okay, and what you want to do is put parentheses around, I always just put parentheses around the second polynomial, just in case I have to distribute that sign. And technically, you could look at this as having to distribute this positive into each one. The thing is with distributing a positive, nothing changes, right? So this is still going to just be a positive times a negative 4c squared is just minus 4c squared. And then positive 7c and then positive 5. So they stay the same. Okay, they stay the exact same. So then this one is still just 6c squared minus 2c minus 1. All right, so I'm going to go ahead and take this and move it. I'll just go ahead and make a copy of it and move it right up here for you guys. Okay, so this is what we're working with here. This will give us the answer E plus F. Sorry, I'm moving stuff around a lot. If I like paste it as an image, it hides behind the image I took from Khan Academy. All right, so our next step is to solve, or is to combine like terms. So I just start on the left. So I have a 6c squared and I have a negative 4c squared. So the c squareds will go together. Okay. And then I have negative 2c and a positive 7c. So those c's will go together. And then I have my constants. I have negative 1 and a positive 5. So my constants will go together. And luckily it worked out nicely that that will be in standard form. So 6c squared minus 4c squared is 2c squared. Negative 2c plus 7c is a positive 5c. Negative 1 plus 5 is a positive 4. So this is your answer. The exponents are descending from left to right, which means they're getting smaller, and then your constant comes last. So this answer would be 2c squared plus 5c plus 4. And that is in standard form, and it's all simplified. Okay? So pause the video if you just need to get that down, because I'm going to go ahead and do the next example. All right, now this one is subtracting polynomials. Okay, so let's go and see here. It says your answer should be a polynomial in standard form. I'm going to make this just a little bit smaller just so I know I have room to move stuff around. So here it says subtract this equation here, or this expression, sorry. It's not an equation because there's no equal sign. We're going to subtract that expression from this expression. They're both polynomials. So whenever we're subtracting something from something else, the thing we're subtracting goes last. So we're going to take this guy, I'm going to make a copy of it. This expression goes second. We are subtracting that whole expression from the blue expression, the blue polynomial here. Okay? So this would be what we have to simplify. So if you guys wanted to give it like names like A and B, we are subtracting A from B. So this means we're doing B minus A. That would be A subtracted from B. So these might get a little tricky with the wordings, but you guys can do it. I have faith in you. Okay? So now our first step is to distribute the negative. All right. So the 10a squared stays the same, plus 3a plus 25. And then these become a negative times a positive. Again, if you guys want to draw this little cheat here, just to help you guys visualize, a negative times a positive. Again, if you guys cover up the negative and a positive, you're left with a negative. So it is equal to a negative. So we have a negative 9a squared. A negative times a negative is a positive. So we have a positive 6a. And then again, a negative times a positive is a negative. So we have a negative 5. Okay, so now we have to combine like terms. I'm going to make these a little bit bigger just because I'm not sure if, just in case the YouTube video makes them look smaller. Alright, so again, I'm going to use some color. So I have a squareds are part of my terms. And I have a 10a squared and a negative 9a squared. So that will be my first term I'll combine. And that is my highest exponent as well, so it's working out pretty nicely. And then I have a positive 3a and a positive 6a. So those two terms are like terms, so they will need to be combined. And then last but not least, we have our constants. So we have the positive 25 minus 5. So those are our constants here. Okay. So here we combine our yellow ones, our a squareds. 10a squared minus 9a squared is just 1a squared. Again, though, you don't have to put the 1. This is really just a squared. The 1 is a given. It's an invisible 1 that we know is there, a squared. And then we have positive 3a plus 6a is positive 9a. And then we have 25, positive 25 minus 5 is positive 20. So your answer for Khan Academy would be a squared plus 9a plus 20. And that'll conclude my video. So go ahead and make sure you guys do these practices before you leave class today, just so you don't have to worry about any homework. I will be looking at your Khan Academy, so please do it. Email me if you have any questions or concerns, and please make up any late assignments as soon as possible. Read my Google Classroom posts. I would like you guys to make them up by Friday, tomorrow night, because I do want to try to figure out ways I can volunteer and help with all these fires going on. So please make up your work, all right? Have a great day. Email me if you need anything.